Hi and good morning. Today we're going to talk about APIs and platform as a service. We have Sam Ramji with us, former Apigee and now head of the Cloud Foundry Foundation.
It's true.
It is true. He was a former Apigee, and I guess you stay one forever. I think you can.
It's like a tattoo.
Exactly.
You'd have to get it removed with a laser. I hear that's painful.
Yes, yeah. Martin Nally, who is VP of Software Development at Apigee, and myself, Ed Anuff, VP of Product Strategy. So what we're going to do today is we're going to have Sam do a talk about Cloud Foundry. We're going to follow that up with some conversations about APIs, where they fit in the mix, and then open things up to questions. And I think you'll find it a pretty interesting webinar. So take it away, Sam.
So good to be here. As Ed mentioned, I was at Apigee for 5.5 years. I was Chief Strategy Officer. I left in January to start my new job on January 21st, 2015 to be CEO of Cloud Foundry Foundation. So it's been a very fast 6 months. We've learned a lot about the market. So I wanted to offer a sort of contextual frame. Why do you do platforms? And then land that in a conversation with Martin and Ed about APIs and where the metal meets the road. So it's become commonplace to say that we're at the dawn of a new era. We have supercomputers in our pockets. We use them to communicate via Twitter, if we have Twitter handles. Sometimes we even make telephone calls on them. We also drive supercomputers down the road. If you look at the compute power of a smartphone, in this case the latest version of an iPhone, this actually has the computing power of a mouse, actual biological mouse, right? The brain of a mouse. By 2022, this will have the capacity of a human brain. By 2035, it will have the capacity of every human brain that's currently alive on Earth. So these things are getting smarter. It's kind of obvious that that's changing our behavior, and now as things are getting cheaper and easier, we're starting to put internet on all of the things, right? Devices are getting smaller, screens are getting easier to build, you're getting cheaper network, storage, compute. So you want to get information wherever you are. You expect to be surrounded by computing. So a lot of businesses have recognized this and they've shifted their behavior. But those who haven't, the stakes are pretty high, right? As we go from putting internet on all the things and making people happy, giving them an opportunity to do commerce. We've also seen this the fastest changing time in business history. So since just 2000, 52% of the Fortune 500 are no longer on the list. It's not just our imagination that things are speeding up, they are actually speeding up. And I'd encourage you to take a look at the end of competitive advantage. This is a frame of reference that Rita Hunter-McGrath, who's a professor at Columbia Business School, has put together, doing the exhaustive quantitative searches to see, what happened in the 80s, what happened in the 90s, what happened in the last decade, what's happened in the last 5 years. The sense is that the old frame of reference of competitive advantage is given away. Competitive advantage used to mean establishing dominance of market niche, controlling prices, locking in customers, and being able to take every aspect of your business and exploiting that advantage as far as possible. So every new dollar you went into the business, you found a way to extend the dollar advantage you had in your old business. Those advantages are fleeting though. So she claims that there's a new framework. We've gone beyond Porter's 5 forces of competition, and now you need to have a new model that you build your company on. I'm just going to be very brief on the first 3 here, but I think they're relevant for the framework. First is continuous reconfiguration. This idea that your corporation itself, even at a global 2000 scale, is something that is code, right? You need to be able to change your organization structure, change your businesses, enter businesses, exit businesses, look at your company as a portfolio so that you hold on less tightly to dying competitive advantage. Second, options valuation is crucial. We see, and I saw at Apigee for many years, and we see within Cloud Foundry customers that one of the things that stops companies from transforming digitally is that they can't figure out how to spend the money because they're going on a discounted cash flow analysis. They're using old tools like EBITDA as opposed to looking at new mechanisms like what's the cash flow return on my invested capital. And most importantly, options valuation. Options valuation is a way to establish a specific financial value to make a choice now that will give you more choice in the future rather than getting stuck into a single path. So it's been used in IT strategy initially for about 10 years, but it's still just barely becoming well known in the strategy community in general. So I recommend you look into it more deeply. And then third, constructive disengagement. How do you tell a group of people who've been operating a business for 10 years, hey, congratulations, we're getting out of this business? That's difficult. So constructive disengagement is this idea that you can have a cultural program that says you can declare victory by leaving a business, freeing up that capital and moving into a new one. So it's the sense that business is more continuous than it used to be if you're going to be a winner. And finally, the thing that I care about most and spend most of my time on is the innovation proficiency. So let's dig into that. You hear about Amazon and Netflix as great innovators, but as you know, one of my pet peeves is when people generalize on outliers. They say the Amazons of the world, the Netflixes of the world. Actually, there's one Amazon, there's one Netflix. That's sort of logically dishonest. But what's really interesting is that companies like Allstate, GE, and Lockheed Martin are actually applying some of these sort of cloud-centric continuous innovation approaches. So I wanted to dive into that a bit.
Right. Well, if it's a digital revolution, then it means that by definition there have to be 498 other companies that occupy that Fortune 500 that are capable of doing it.
Absolutely right.
And the third isn't Google, sort of Alphabet now.
Sorry, Alphabet
Yes.
is ABC.xyz, you heard
Right.
it here second.
Yes, exactly.
So this idea of continuous innovation sounds a lot like what we're doing in modern IT, right, in modern engineering, which is built on a stack of continuous integration. You check in your code, it gets smoke tested, you've got a good master copy, it's all constantly being built, right? You can check in your code a couple hundred times a day, right, across a team. Continuous deployment means being able to take your code and push it all the way to production once it's actually met that integration boundary. It's smoke tested, it hasn't broke anything in the build, but is it actually going to be good enough to go all the way to the servers? So that's where you start to see the continuation of CI into CD. You've got an end-to-end pipeline. Now, 5 years ago, the state of the art for CD was Zynga, right? They deployed, 40 times a day?
That was what was reported, yeah.
And last month, Amazon came out and said that they now push code to production every 7 seconds. So you get a sense of how vibrant businesses are built out of this system, and that takes you to this frame of continuous innovation. Interestingly, there's a huge breakdown in people who want to achieve continuous innovation because they do prototyping, they do demos, and they don't have access to the production servers. And so when you remove access to production servers, when you don't have a way to get that code all the way out, you kill continuous deployment, and instead you're stuck in an anti-pattern. You know what that anti-pattern is called? It's a waterscrumfall. If this sounds horrible, then you're getting it. And many people are experiencing this today. They've got a great concept to demo process. Their demo's working great. The marketing team's excited. It only took 4 weeks to go, constantly iterating, seeing a better and better user experience. And then finally, they're done, and they say, when can customers see this? And then you file a ticket with IT. And IT says, yeah, we'll talk to you in a month about your requirements. And then that leads you into a 2 or 3 month process to be able to get your servers. And then you'll finally, maybe sometime, see the light of day. Because traditionally, classically, IT operations has maintained high availability by drastically limiting change. You get your 5 nines by not allowing anybody to change anything, basically.
Yes, the JIRA, the backlog of broken dreams.
So the move forward, right, is basically a formula of pairing cloud-native applications with continuous delivery of business value. What you want to understand is what's the structure of a cloud-native application so that you've got the right-sized widgets, right, to move around the system with a new frame of reference that says our business is about not 18-month cycles or 12-month cycles, but maybe 18-hour cycles, maybe 5-day cycles where we're rolling those over and we're working across the team, both operations and business. And this is the path out of the waterscrumfall.
You need to put that on a t-shirt.
/ waterscrumfall?
Yeah,
we'll do
exactly.
that.
Yeah.
I think we'll do that today. Cafe Press.
Right, there you go.
Send you
continuous innovation.
Send you each copy. Put
Exactly.
a Cloud Foundry logo.
Those are
Yes.
the kind of t-shirts you pay to make, not the ones you make money on.
That's exactly right.
Exactly.
So just to get a sense of sort of what this world looks like, it looks like microservices, small bits of code running, doing a specific job, communicating with other parts of your application, sort of your larger distributed application through HTTP, right? Standardizing interfaces, using APIs. They're typically getting deployed into containers, right? Small, reusable, serializable, and that's the really important thing. This is a serializable format for what a server looks like, rather than building them from scratch, treating them very carefully, or using a lot of command line codes or even command line scripting to get them in shape. You build the image once, you build it as a lightweight container, it contains a microservice, and you push it out to your test and stage and production environments. And then finally, 12-factor applications. So this is really where you start achieving web scales, when you factor out all these other dependencies that are inhibitors to being able to blow up any container at any time. You want to say persistence, that's in a service. Access to CRM and customer records, that's in a service. Journaling, that's a service. The only things that we have Resident in a 12-factor app is the actual code that deals with the concerns of the application itself.
So you draw a straight line really from sort of global competitive advantage to scalable containerized workloads.
Absolutely, as long as it's mapped into this continuous delivery of business value, right? So you have to not be doing it for its own sake, but what we keep hearing is that business people are like, we know we need to move faster. IT says we're moving exactly as fast as we need to, so these two forces don't work. You need to have a system of smaller teams and faster tools that allows those teams to trust each other and start to roll fast. Those are really the teams that are winning. Think about the work that you've done with Burberry.
Agreed.
Right, that's a team that moves very, very quickly.
Absolutely.
And they build competitive advantage in retail.
And they actually are using scalable containerized workloads.
Exactly.
And an awesome response to my snarky comment. You just rolled with it.
Absolutely. So this world is ephemeral. The containers should come and go. You shouldn't feel precious about them. Right? It's like managing a fleet. You don't worry about if one of your trucks malfunctions. You send it to the repair shop and you get another truck on the road, right? So these things should be able to come and go.
Or even better, you throw it away and buy a new one.
Well, you have to have a lot of money to throw a truck away and buy a new one.
That's what's happened with consumer electronics. Right?
Exactly right.
Nobody fixes a small camera anymore.
Exactly right.
Because you cause more problems than you fix, and it costs a lot of money, so you just get a new one.
Yeah. So what we used to call
you can do that with containers.
What we used to call built-in obsolescence is now ephemerality, and it's an attribute if you're trying to achieve scale, right? Because scalability says this week you have 100,000 users, maybe next week you're very popular, you have 1 million users.
Okay.
How are you going to scale up? Well, if you have an ephemeral system, you grab more servers and you say, well, we've already got a containerized workload, we're now going to scale that up. Maybe the week after that, you only have 500,000 users.
Yeah.
So we need to be able to scale down, right? It goes in both directions. And then agility comes from shrinking the amount of code, right? And separating all the dependencies so that we can update one little bit of code in one place with one container, maybe on a dozen servers, and that incrementally improves the customer experience, right? So that's the system that we live in. So looking further at cloud native applications, briefly in terms of the architecture, right, we've got 3 key requirements, right? We need to be able to run in the cloud, support any client device because they're coming and going, as Martin mentioned, and we need to connect to legacy data and processes via APIs. It's not the only place that you use APIs in architecture like this. But the first piece is it's crucial to be able to run in the cloud. You want to be able to take on-premises clouds, right, hybrid clouds and public clouds, so that you don't have to have a provisioning process for your server that involves purchase orders and humans. You want to be able to know that you've got a managed environment, that you have an API call that gives you more servers. What's interesting is that many of us have forgotten the lessons of the past, which is whatever you write today, if it's successful, needs to be in production for years, maybe decades. So when you think about when's the code done in this world, it's done when nobody uses it anymore, not when you've finished writing it. So this idea of what cloud do we need? So we believe with Cloud Foundry that you need to be able to run on AWS, you need to be able to take that same code, run it on DigitalOcean, on vCloud, on OpenStack, on bare metal, whatever comes up. You need to be able to support any device because we don't know what device we're going to deal with next. Whether it's going to be a browser client, various mobile devices, cars, industrial internet. One of the best demos we had at the Cloud Foundry Summit a month and a half ago was Harel Kodesh, the CTO of GE Software, had a demo, CF push wind turbine.
Nice.
Right, so pushing code out to run industrial internet devices, you never know. And then finally, the framework inside the platform needs to not just support custom applications and to be able to support all that scaling, but it needs to call things that are in your enterprise. In some environments, like in Bluemix, you can use IBM Watson, right, a large-scale machine learning environment via APIs. If you run with Pivotal, you'll get access to their depth of analytics, right, storage, Azure, same thing. But you'll go out of business if you think that the cloud is all about the cloud. You need to be able to stay in business, not join the 52% of the Fortune 500 who left the list.
Right.
You need to talk to your legacy, or you need to be able to talk to mainframes.
And this has been, I think, this seems to be a really important key driver. I mean, a lot of the early PaaS stuff and people, using services like Heroku, those were a lot of greenfield apps that sort of were largely self-contained, or data that was sort of bulk upload. There wasn't sort of that, they weren't live connections to these existing enterprise services. So this seems to be sort of the thing that people are finding is what's making this type of architecture necessary.
That's right. So as we'll probably get to later, right? It's built on being able to have a service broker.
It's the same idea that people sometimes call two-speed IT.
Sure.
Where you need to be able to connect to your legacy, but you need a newer environment that allows you to go quicker on the front end stuff.
And if you lose the ability to connect your systems of engagement to your systems of record, you've got corporate amnesia, and you actually won't be able to do business. Some people don't realize that they're their awesome, iPhone app that lets them trade stocks. Your stocks didn't go anywhere through the app. They didn't go anywhere through the web systems. They didn't go anywhere through the middleware. They didn't actually move until a command hits a CICS application running on an IBM mainframe to move a record in a database that's on that system. That's when the money actually moved. Right? Nothing happened until that point. So we ignore legacy, I think, at our peril, and this is hopefully something that we can all keep at the front of our mind as we build the new greenfield systems. Let's not get too carried away with the new, right? So switching gears from the cloud native applications, looking at the continuous delivery of business value, sort of the second half and ending of my part of the talk. I think this is a crucial thing for everybody who's building APIs, because anybody who's listening to this webcast has seen this challenge, right? APIs let you move fast, and often that's about the technology and about the ease of connecting, but they overlook the fact that you need to change how you work, right? It's actually the only choice that you have. Digital transformation is about changing how you work. You need to right-size digital innovation. Right-sizing is a term from Toyota in the 50s and 60s as they were reinventing manufacturing, a system called lean manufacturing. And the idea was not, build me a US-based factory where you can pump out 50,000 cars per day. Get me a new system where I can focus on cycle time optimization. Can you get one car end to end in 30 minutes? Because as we start to right-size the whole system, smaller teams and faster tools, we can be more adaptive to changes in our suppliers, changes in demand, changes in the latest technology. And one of the hidden costs of those giant systems that would produce 50,000 cars per day is that it would take you a week to reset the system to build a new product. And that is not containerized workloads and continuous delivery of business value, right? That's sort of waterscrumfall, right? Right, putting something efficient in the middle of a big chunky process. So just give you a flavor of why we do this, right? So this concept of two pizza teams is crucial. Not everybody knows what a two pizza team is, but it's a term from Amazon, which was then used at Netflix and more broadly now. If your team is too big to be satisfied with 2 pizzas for dinner, it's too big. It's really important because you start to break down the silos as a result. If you can only have 2 pizzas to feed your team and you need design, development, operations, and product management in there, it makes you start to think about an integrated team that's really got its hands on the business. And this is why we use the framework of continuous business of delivery value.
Yep.
So now when you're hiring people, you need to ask them whether they're big eaters or not as part of the interview process. Yeah.
There'll be scales and well, I guess your team would be smaller if somebody was really hungry. Like my son eats about half of the food in my house, even though there's 4 of us. So he would have to work really hard to earn his way.
I found the 2 pizza. That was my main issue with the 2 pizza teams. Is first of all, I was just like, it depends on the pizza, but I think you're not going to have a very large team with that.
So why is that though?
Well, 6 to 10 usually.
Large teams are bad, right? So just as IBM was inventing CICS, many of which are still running workloads today. And virtualization was being invented 10 years later on the mainframe. Melvin Conway in 1967 recognized something that we still deal with today. This is just an emergent fact of human behavior. Right? It's called Conway's Law, and I haven't seen it disproved. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Why does that point us at small teams with microservices? This is an observation by James Lewis and Martin Fowler in their outstanding article, Microservices. Basically it points out that you typically have a big team. You've got a UI team and a server-side team and a database team, and maybe you've even got another set of client logic. And when you separate them, even small changes lead to cross-team meetings, budget problems, scheduling problems, sequence problems. And so then you just optimize around what do you have control over, right? So, let's all admit it, there have been times when we haven't had access to the code and we've said, we're just gonna make this change in a stored procedure. Right? And then we end up with the evils of, I don't know why the code's behavior changed.
Or we'll build it into the UI, even though those persistence function. Yeah.
We'll build it into the UI layer. We're just going to call more APIs from the UI layer, even though that adds like 4 more network hops, and all of a sudden the performance
and the guy down in the corridor is doing the same thing. Yeah.
Exactly. Right. So I love how James and Martin put this: logic everywhere. In other words, or as hyperbole and a half might say, logic in all the places.
Exactly. Well, so and it's interesting. There's this whole thing now of the concept of technical charity, which is when you look at other people's code, you should not assume that they were idiots.
This is the opposite of technical charity.
No.
We're
It's
going to
actually,
give things away.
a little bit. It's actually more about the idea of giving a little bit of goodwill towards that engineer down the hall who stuffed the persistence into the UI tier on the fact that either it might be an architecture or a deadline or something of that sort. So I found that interesting. There's a long thread running on Hacker News on that subject right now.
The server-side cache wasn't working, so we just
Exactly.
packed up an extra cache on the client.
Exactly. Yes, we've all done that.
Don't worry about the security problems that
Right.
I just introduced. So that hopefully helps you see the sort of the permanent nature of how we build software and why, as we're starting to figure out how do we make software move faster, we need the teams to be smaller, right? So you take 100 people and you split them into 10 teams, right? You don't have those 100 people organized into 3 teams because that's the old way. That keeps us slow. So really, the secret is about combining dev and ops, right? We all know that, I think we've each got experience that engineers who carry pagers write better code. Right? When your pager goes off at 2 a.m. and you've got accountability for this stuff in production, you find a way to not make that problem happen again.
I think in the long term that's true. I think that what you're finding is if engineers have control over the scope of the work and can design that, and that everybody has that responsibility for gaming production, I think what in the short term what you hear a lot of engineers say is I'm not writing better code because I was up at 2 a.m. and didn't get enough sleep.
It's all longitudinally.
Exactly.
But if you had a cook who never had to do dishes, they'd probably be the messiest cook in the world, right? So it's good to have it.
Yeah.
For a cook that never had to eat the food. Yeah.
A cook who didn't have to eat the food and didn't have to do the dishes, that's kind of classical enterprise software engineering, which now we're trying to change, right? All right, so coming into the home stretch here, so this is a path out of the waterscrumfall. By combining dev and ops, having smaller teams, but you can't just have a smaller team and say, well, keep doing monthly or quarterly governance, keep using Outlook as your system of record for what your contracts are. You need to make tools that actually work at the speed that you have. Again, back into lean manufacturing, they had mistake proofing, poka-yoke, right? So if you could put too much tension on a particular bolt and torque the head and then have to redo the entire operation, maybe drill out the bolt hole, they'd give every technician a ratchet that would start spinning at a certain tension point before the bolt head would come out. The system itself was smaller, faster, tighter, easier to change over. So this world looks like we communicate in stories rather than having big ideas, architectural plans, things that we might get to down the road. There's a new thinking, which is YAGNI, right? You ain't gonna need it. So stories are really, as a user, I'd like to do this, and it keeps us focused on user value.
So, interesting thing is that I want to call out on this one. A lot of people in DevOps talk about, sort of automation as the key to doing things, and what they often neglect is actually they get all focused on automation on deployment. When you call out all 3 of these, when you actually see a really efficient working team, what you see is that you see the integration between HipChat or Slack and their Jira and their analytics. So interesting thing when you're thinking about automation and integration is look at how that affects sort of the human dimension too. It isn't all about automation on how quickly can I spin up servers, it's actually automation on how quickly can I get the health of those servers piped into the Slack chat room. So it's not even a question of getting paged at 2 a.m. Running up to that, there were little alerts coming in from your Splunk or New Relic into the chat.
That's exactly
and
right.
Everybody in the team is aware of that.
That's exactly right. It's about changing the speed at which information flows
Exactly.
and is shared among the team. I can't imagine working without Slack now.
Right.
So people who are building these things, you'll know because they've got Slack on their home screen on their phone. Or HipChat, right? It's a faster way to go. And then again, to your point, dashboards. Dashboards allow us all to know where the system's at all times. In the olden days, dashboards were only in IT. Right. But when developers can see the dashboard from New Relic or Splunk or wherever, they can start to respond outside of pager time, and everybody can start to see the performance begin to tip over.
Right.
One interesting thing is we use a term called Kanban, right, in Agile. Many people don't know or have forgotten that Kanban is actually Japanese for signal. So that's what this whole system is.
Right.
We receive common signals, we can act as one unit, we can go with one effort, and we can make it work. But the team's got to be small enough that that's coherent. On the infrastructure side, right, so this world of continuous delivery of business value looks like Docker and Rocket. Recently, Docker and Rocket combined a set of their technologies and made them both open source and multi-vendor in the Linux Foundation, a project called RunC. The top level project is called the Open Container Initiative. And so that's two components. It's a file format
Yeah.
and a runtime, which is becoming an open standard. So that should simplify how we do automation, because now we've got common pieces to move around. We don't have to do a long inquiry into which container technology we're going to use, right? There's standard format. And then finally, cloud management. You see systems, the cluster management systems like Apache Mesos and Kubernetes, and Cloud Foundry, which spans automation and cloud management. It's a complete stack that takes care of putting containers under the covers, taking new containers, pushing out 12-factor application code, and managing that state across a large field of machines, and dealing with sort of self-healing, auto-scaling up, auto-scaling down types of problems.
And the rate that these are cross-pollinating and consolidating is really amazing to watch. I mean, just in terms of evolution of the industry, and even, the whole Docker evolution, to open containers and so on.
Yep. It's been super fast.
It has been, and even on the Cloud Foundry front, the rate that things like Kubernetes and the containerization has been sort of embraced and so on. And I saw this at the Cloud Foundry Summit. It was very encouraging to see. These are things where sort of, viewing in the past, you'd see these different technology paths that would go off in their own directions, and they'd have their adherents, and you'd end up in this sort of fragmented world. Whereas it seems at the moment, and maybe we're just sort of, in the middle of sort of a very short-term golden age, but it seems like there's a lot of communication going on between all these projects. People aren't really sort of being standoffish and saying, oh, well, we don't like it that way, or even where you see these rifts, they end up sort of coming together in a very short amount of time. I mean, for a while there, it looked like Docker was going to be sort of split off in different directions, and now it's got a new governance model, and it's looking to, and it's playing well with the rest of the ecosystem.
It's a really good point. I think we might have reached the age of foundations, right? Because part of what's happened is open source has gotten very popular. Everybody's figured out sort of some basic monetization models. That's also added to some of the rifts. Open source, of course, was never kumbaya. Right? It's always been a place for violent conflict about ideas to get pulled into different shapes and different directions. But if you look at sort of what you talked about with Docker and Rocket into OCI and runC, Node.js into Node and IO, and now come back together in the Node Foundation.
In a very, very short amount of time.
Right.
Relatively speaking. I mean,
exactly.
At the time, that whole rift was probably 3 or 4 months in its entirety.
Yeah, but it was a huge rift, and it came back,
exactly.
right? Kubernetes is now part of the Cloud Native Computing Foundation. Cloud Foundry, part of the Cloud Foundry Foundation, and these things all work well together, because when runC came out, right, we immediately looked at it in the Cloud Foundry engineering community and said, wow, this actually solves a lot of issues. We can start to contribute some of the things we put in our container technology called Garden. We can contribute that into runC. So I think we're all starting to get a little bit better sense of, the fact that we all have a responsibility to make technology work better, and that we have some of these frames of reference, right, of these governance systems that allow us to have those conversations and implement them in code so that they work better. So that's my hope. And Swagger, I think, is coming.
It's extremely important that these things
way.
go in cycles, and they have done since I started working, which is, you can tell, was a long time ago. So, you get these kind of periods of consolidation and periods of let the flowers bloom. And the trick is I actually think the trick is going from the flowers bloom period and having the timing be right and the choices be right to go to this sort of consolidation period. I think we've seen some cases where actually that didn't work so well, where things were sort of prematurely or without sufficient validation.
For sure.
And then you see the opposite problem where the flowers bloom for too long and there's just kind of complete chaos, and you get kind of destruction of value. And you talked about the fact that some kinds of software, successful software, has to live for a long time, and that kind of software needs a stable base to build on. So total flowers bloom. So you have this kind of cycle that we go through.
I think the forcing functions are people building real things on them, because I think that what happens, and this is, and I think the point about long life cycle becomes very important. I mean, that's part of why, in the JavaScript world, you see so many UI frameworks, because the UIs get redesigned every 6 months, so a long-lived UI framework doesn't become as important a thing. If I'm going to throw away my UI and redesign, the latest and greatest, I don't care that, whatever, jQuery's been supported for 10 years, It's like, anyway, let's keep moving, because we've
so just taking a couple minutes to talk specifically about Cloud Foundry. So Cloud Foundry, as an open source project that's part of a neutral foundation, is actively being shipped by rather a lot of vendors, actually. So Pivotal Cloud Foundry, Pivotal CF, IBM Bluemix, running one of the largest installations, probably the largest installation of Cloud Foundry in the world. HP Helion, HP recently announced that they're acquiring another one of these logos, Staccato, from ActiveState, pushing that out into telecommunications, making that the basis of their cloud development platform. CenturyLink has done some amazing things with AppFog, a company that you and I know fairly well.
Yeah, and great stuff with containers too. Folks over there are really sharp.
They're super sharp. SAP is making it the basis of the HANA Cloud platform. It was just announced and launched by GE as the basis of Predix, which is GE's cloud for the industrial internet. Huawei is launching their public cloud for telecommunications carriers, because it turns out every telco is not big enough to run their own cloud, and there are hundreds of telcos around the world who need to be able to have part of a telco cloud. So Verizon, Accenture, Canopy. Accenture just down the road, this is the basis of the Accenture Cloud platform. And Canopy, which is part of the ATOS group, does the same thing. So this is where we are. Expect to see this expand. My favorite thing in closing is what's different about Foundations, I think, is our opportunity to flip the table over and make sure that there's a great ecosystem with lots of supply, but to serve the users. And so here's my favorite headline from this year. Right, so this is users of Cloud Foundry in the Wall Street Journal saying Cloud Foundry prevents vendor lock-in. There's this idea that we make sure there's an open standard, a common core, a set of bits that everybody has to use, so that the applications themselves are portable. So this is what we're trying to achieve.
It seems like it's been great progress. So let's transition off to how APIs fit in on this, and this actually was your last slide. So,
right.
but a great kicking off point of a digital platform equals APIs, and obviously, Apigee is very interested from the standpoint that it's within Apigee's mission to try to make all usage of APIs better. One of the things that's really useful is sort of understanding what do we mean by APIs, and this is one of these things where every time I ask this question in a room full of architects or software developers, everybody's like, of course we know what APIs are, and I'm not even talking about the distinction between the APIs that you use in the code level and web APIs. I'm saying just even among a bunch of folks using HTTP-based web service APIs, where do they sit in the architecture? And this is kind of useful for thinking about, this review will be very useful for thinking about where this sits in when you're looking at something like Cloud Foundry and how APIs relate to it. So obviously the first web service API was your browser talking to your web application, and over time that's been sort of abstracted to be your front end talking via an API to your apps, and in fact most apps today, mobile apps and so on, but even web apps are not even using sort of traditional rendered pages. You're seeing a lot of JavaScript that's pulling the output of REST APIs to display their UIs. If you ask a bunch of front-end developers, going back to the comments about jQuery and all the front-end stuff, and said, hey, do you guys know what APIs are? That would be what they would think of. That API that they use to go and deliver something to their front end might be as mundane as an autocomplete API. It could be something a lot more complicated, continuous scrolling and so on. A lot of stuff on the front end standpoint. Mobile people obviously spend a lot of time. In fact, everything in mobile is powered by an API. Second, area of APIs, and this is where contrast this to going and talking to a bunch of web developers south of Market in San Francisco versus going talking to a bunch of enterprise developers. What do you mean by APIs? This is where you start dealing with the architects who've never actually seen a front-end application, or at least they would purport not to have. For them, it's all about shared services and sort of creating that perfect API that's going to allow application reuse, and that's sort of the back-end shared services. Now, this idea isn't unique to enterprise APIs from the standpoint of thinking about shared services. You also see this within 12-factor apps and so on, the idea that sort of all of the resources your app needs should be exposed.
Right, it's not just a legacy. This is Cassandra, right? This is Mongo and Ryak. This is whatever you might want between
all the databases as a service you see, whether it's a DynamoDB or a SimpleDB or Google's 12 cloud databases and so on, or actually I think they're also under the Google name. was going to say the alphabet databases.
I like that this is so app-centric. I wasn't sure if I was trolled or corrected on Twitter recently by taking an app-centric view of infrastructure, and someone said, oh, well, without the services, apps would have nothing to do. And I was like, God, that's interesting.
Well, so this is also an interesting point. And actually, a lot of people, as you can imagine, Apigee goes out and talks to folks, and they go and say, "What's the difference between APIs and SOA?" And my response is always, "It's right there. It's right there in the letters." APIs fundamentally are about increasing application agility.
Yep.
At least in terms of how we view it, and I think that it is. I think that that's correct. You're talking about more applications, more developers building more code for more applications, whereas a SOA architecture is fundamentally about building services with very little concern as to what people build against it. And
as my 6th grade teacher would have said, the difference is you put the emphasis on the wrong syllable, right? Because in an SOA, frequently we found year-long processes led by architects to have a standard XML representation of the single true view of a customer or a flight or a passenger. To what use? Right, so that you could have a common, metadata dictionary that you could use for dynamic translation that nobody ever did, because either it surfaced in a "your bags are late" app, or a "rebook this flight" app, or it was useless.
Yeah, basically, if you develop.
It occurred to me while you're talking though that there's two different perspectives. If you're talking about you're trying to interface with your partners, you put an API in place because you're trying to enable a communication that was previously different.
Yep.
But if you're talking inside a system, you might be trying to do the opposite. You might be trying to establish a clear contract where the alternative was actually too much communication that caused a big spaghetti mess.
Absolutely.
The purpose of making that contract can be different according to the context.
The question is whether you want sort of the contract to succeed or not. In that if I was going to do business with you, I could create a contract that you wouldn't sign, or I could create a contract that you'd be like, yes, that's awesome, that's a win-win. And so I think that you're right. What the goal is, contract being once defined avoids the need for sideband communications. But it does have to be, you need two parties for a contract. And I think that's a lot of people coming from a SOA standpoint. And again, I'm talking against straw mans, and some people will go, get very upset at me for that, but I'll still say that, all too often people go and say, well, so the application, is that's calling my service is irrelevant, and usually my response is, that's right, you've made your service, irrelevant to all applications because you didn't think about their use cases. And so it's really has to be good for at least one use case before it's good for a whole bunch.
So how does this connect with something absolutely horrifying that I heard recently, which was a phrase, an API bus? So for me, that just makes me think, okay, so some SOA-centric people followed on their enterprise service bus and then decided that doesn't sound sexy enough anymore, so they have to use the API expression. Can you have an API bus?
Can you have an API bus? I'm withholding judgment.
Or is this like a Zorse? Is this like half zebra, half horse, all donkey?
I love that. I didn't remember that one. So I've seen this term API bus appear in a couple of places, and I think that. Well, actually, I'm not going to withhold judgment.
I was going to say, Ed, you're being totally unreasonably, uncharacteristically patient.
I am still going to be diplomatic, which is I can see why some people would really want an API bus, but I think that's a bus I don't want to get on.
Get off the bus, guys. Is that like somebody saying that polo shirts are cool, so people who are still wearing polo shirts can feel cool?
Hey, polo shirts can be cool. They can't come back.
That's not true.
You're
just wrong.
Anyway,
you're outnumbered 2-1 here.
So then, anyway, going back to our roundup of APIs, your app-to-app APIs, and this is sort of, integration scenarios or just having apps talking to each other, and then sort of the next to last, not the final emergence of APIs, but really where we start to see a lot of people starting to actually worry about APIs. Interesting thing is probably in those 4 previous uses of APIs, I think people should be thinking a lot more about them from the standpoint of monitoring, analytics, security especially. But for whatever reason, people tend not to get as caught up on the fact that, hey, I'm doing an API, until suddenly they go and say, these APIs are actually being used by applications external to my organization, and my application is being dependent on services external to mine. And that's where suddenly people are like, oh my God, I'm doing APIs. Though I really think that realization could have happened way earlier.
But frequently it doesn't, because people are rationalizing about how the new thing they're doing is just the old thing they're doing.
Well, and I
but
think
it's not until you start to expand and API all the things that you realize how much the world's changed.
Well, people have perhaps an unrealistic view of sort of the sphere of control that they have for API usage that is happening within their team or teams that they have line of sight to. And suddenly they now have to deal with an external constituency that they either are providing or having a dependency to, and suddenly it's like, oh my God, now I need to do API management. And then the final piece
Yes.
is microservices.
Exactly right.
Which is to go and say that the APIs are actually within the boundaries of what I used to call the perimeter of my application.
Yes.
This slide has gone and done an unfortunate little effect in terms of.
Do you like that you used the Greek micro letter?
Yes, I do. Well, micro wouldn't work, but it would. Spelling it out wouldn't have fit.
But it's a consistent. I like how you describe it as being the boundaries are falling away, right? What is an app? Well, an app is a collection of microservices that's serving a coherent function. It's built by maybe a 2-pizza team, right? So these things are moving fast. Maybe you lose a little bit on documentation. You make it up in speed for now. Where does that all go? It's very similar to what's happening with security, which is like zero perimeter.
Well,
you don't start with the
That's
idea that I'm going to
interesting.
do this for me and I'm going to do that for you. We're all going to do the same thing. Everything's going to be pluggable, right? Much like the Steve Yegi rant, relaying the Bezos mandate from 2002.
Yes.
That led to sort of the bloom of Amazon Web Services. Everybody will communicate between every internal service just like they would make an externalizable service for a third-party developer. That's a big change all the way down into what used to be libraries and internal application architecture. Now it's microservices, so that internal architecture is even sort of right-sized and transparent.
So the interesting thing is, and this is and I'm sure Martin will jump in too on this too, because we've been spending a lot of time thinking about these things. What has been the difference between microservices and SOA approaches? I always maintain. So actually, going back to the original Amazon rant, they actually in that document they called what they were doing SOA, and I think they were actually correct. And people at Amazon are going to go and kill me and so on. But I actually do think what Amazon was doing was SOA. Not that that's a bad thing. As Apigee says plenty of times in our webinars, SOA it's a design pattern and not something that you can do right well. But it is intrinsically right or wrong. You can do it right or wrong.
But Amazon won't kill you because they claim that their drones are only for delivering goods.
That's true. But they could drop. That doesn't mean that they can't drop something on you.
Fair enough.
The offensive capabilities of a delivery service that need to be explored. But the point is that this I actually think, for me anyway, and I know there's a lot of interest. I know that Martin, I'm going to hand things over to you in a second on that. They're very interested in a lot of the technology and so. I think that there's a lot of governance issues around this, and I don't mean governance sort of in like the let's turn into police state standpoint, but I mean in terms of anytime you've got dependencies between teams or even between individuals that are not purely reflected in the contract, and of course the hypermedia advocates would say if you're doing hypermedia APIs, you don't need any sideband communications ever, but the point is that you do now have a new set of dependencies that you didn't previously have that is actually at a deeper embedded level in your application architecture. I think that's something people are going to have to deal with.
I think one of the things about microservices is it relates closely to what Sam said about Conway's law. So if you're going to try to establish these kind of 2-pizza teams, then you have to address the issue of how two pizza teams talk to each other, and in particular how the software that they produce talks to each other. And the model of treating those teams as having a sort of a partner contract between each other, is the natural place to look for a solution to that problem. So it makes total sense to me. In fact, my experience, working inside large organizations, I worked for IBM for a long time, and you see exactly this kind of phenomenon. That the most successful teams in terms of producing software that gets broad use are the teams that think about all of their consumers exactly the way that they would think about an external consumer, and they put the contracts in place, and they do focus on the documentation, because you can't build adoption and community without transparency at the sort of words level as well as at the code level. So when I actually think that there's two different sort of thoughts going on in microservices. One is kind of a return to the SOA principles, and a bunch of sort of new ideas around sort of guidance and process and how to use services, to reach the goals that you want. There are also some interesting new technical ideas which are a little bit more obscure, but the sort of traditional view of SOA and services is that a service is a single address. It's an IP address, or it's a DNS entry that I consume. And then what happens behind that, I can't really tell. There's probably load balancers and multiple instances and things like that. But there's sort of a new approach, which was sort of initially most publicized, I think, by Netflix, but which you also see Kubernetes doing and Airbnb and others, where they said, we don't really need that single point in the middle. We're just going to, every instance of every service is going to broadcast its existence to every other instance of every other service. And then the communication, so that eliminates the point in the middle. It pushes more technology client-side. So we've got a nice combination of things. We've got some interesting new technology ideas and a bunch of interesting new experience and guidance around how to manage SOA. And I think pushing us towards, this idea of APIs as contracts being terrifically important. That's how you achieve your organizational goals as well as your technical goal.
Yeah, the idea of pushing out to sort of distributed state, we've seen a huge uptake in etcd. It's a big dependency that Cloud Foundry takes to be able to say, here's the current version of the truth. Here's what all the microservices can depend on. Here's where all the containers are. Here's their performance, right? So that move to being able to share that information more flexibly has partly come out through more resilient distributed databases that we can share the state of an entire data set.
As a practitioner, it took me a while to understand what people meant by API management, and it took me a while to realize that I was sort of aware of the problems that I had, but I didn't realize that API management was the word that people were using for the solutions to those. So I realized, for example, that I needed security on my API. I needed to know who was using it and be able to authorize who I wanted and who I didn't want to use it. Because in this kind of contract-driven thing, knowing who you have a contract with is perfectly important. It's not just about, I'm going to field requests from all comers. The contract is important. And I knew I needed some monitoring. I needed to know, what traffic was coming to where, who was using what kind of service I was giving to people. And I knew I had to do some kind of spike arrest and things like that. But I didn't realize that, I understood the problems before I understood the marketing label for the solution.
Well,
and when I listened to you, Sam, you painted a really nice picture of how sort of cloud computing, and in particular the sort of PaaSes that allow the application to be the unit of deployment rather than a whole machine, how that sort of advances the kind of DevOps thing. So to me, there's kind of in terms of a solution that I need those three layers. I need a kind of underlying cloud that gives me my sort of compute and storage, networking. I need my PaaS layer that helps me deploy the units that are meaningful to me, my applications, and to manage my contact with the services that I'm using. And I need this API management layer above that says, this is how I'm going to manage my contract that helps me deal with my my organization, whether that's an internal set of partners or whether those are external partners.
Yeah, that's what gives you your resilience and your externalization and all those things that you want to do when you realize this is actually your business.
Yep.
So I tend to think of API management should rhyme more with business management than it does with service management. Right? Sort of different domains of concern. It's more like what's the front end of your digital business?
I think
just
that's
like your
definitely
website used to be, right?
Yeah, I think that's definitely true, but I've also found that a lot of approaches to service management didn't actually give you the data that you needed for applying sort of your business management disciplines on a lot of things that were sort of happening kind of off the balance sheet or not with, so
more like SLA and ticketing.
Well, exactly. I mean, when we talk about sort of life cycle and stuff, you see this all the time, which is I can't shut something down because who knows what will break. And
that's a classic problem.
Well, it is. And so, half of the SOA architecture out there, people are like, I can't shut that service down because who knows what will happen. Well, that's why you're actually now seeing this move of API management into more of the service, domain, and part of why you're actually seeing people saying things like API bus, because suddenly, you want that same view. What you're having is the same people who are managing and aware of every mobile app that was calling their API goes, says, this would be great if I knew every, antiquated Visual Basic app that was making a call to these same APIs. I wish I could retire those as much, because right now, if you are, like we see for some of our customers who have, like 26 apps in the App Store, and they don't say, do we really have to keep this endpoint running? Is anybody using this? Can we retire this? People, in the past we've gone to shrug their shoulders. I don't know, but it would be the end of the world if we shut it down and a lot of people start tweeting about it. Now they're like, we got 10 users from that, last month. Let's send every one of them a gift card and say we're sorry. Well, same thing.
That's part of this idea, even at the beginning of the conversation, constructive disengagement.
Exactly.
Right? How do we say we're going to be running this code, and we have to maintain the code, we have to develop the code until it's no longer needed. Well, sometimes we might need to decide this needs to be no longer needed. We're turning it off, and that's how we disengage.
Right.
One interesting thing about API management and the services concept is that you say you can't turn it off. But a lot of where we're getting to in cloud computing is continuous operations, continuous innovation. How do we get into a stance where, we have to take this part down for a little bit, we have to roll this.
Right.
We're starting to see a term called blue-green deployments. So a lot of pre-existing monolithic applications couldn't really be taken down gracefully.
Yep.
Right? You don't really have a hot upgrade. So it's one of the few cases where I've seen a good reason to start to migrate from previous architectures to pulling pieces apart, running it on a PaaS so that you can do a blue-green deploy.
Yep.
So as we start thinking about what we call day 2 operations, right? What is the actual longest term life cycle of these services as we build them out? So being able to meter those, manage them at the API tier, and then be able to support those changes at the platform tier. I think that gets us to sort of the more agile, the more sort of continuously moving environment that we're trying to produce.
So let's wrap things up on a couple of the last slides. So how do these work together? What are the benefits of PaaS versus API management? I think we've covered that. A lot of ability to be very agile in building your applications and all the benefits that come from that. And then from an API management standpoint, being able to drive a management functionality across all of the APIs that are part of your architecture, and actually being able to drive the business insights to that. How do these things work together? It's a little bit of the peanut butter and jelly model. You can just put one on top of the other. But in all seriousness, you do have two mechanisms. You've got the proxy model, which does work very well.
And you see customers doing this, correct?
We see this a lot of this, and I will say, over the last year, the number of folks who are putting API management in front of their platform as a service has been very interesting to watch. Steady growth, steady progression, and Cloud Foundry, at least within the enterprise domain, is becoming, and all the variants of it that you talked about, the Blue Mixes and Pivotal Cloud Foundry and so on, become a very persistent sort of thread of interest that we see. But there's also a lot of interesting areas for a deeper integrated model, and as we say in the slide, stay tuned. Obviously,
this is the beginning of a brilliant teaser campaign.
I think so. Yeah. Go ahead and tweet it. Anyway, let's see if we have any questions. We've run up pretty much up against the hour, but we can go for a couple of minutes if there's a couple of interesting questions that people want answered. So first one, technical empathy rather than charity. I like the concept. So it was a question from Mike out in the audience. Yeah, and I didn't originate this term. I just actually came across it on Hacker News the other day. It was a good reminder of the fact that you should always sort of ask and wonder why something was done. Maybe it's just a function of age for me. I used to look at a piece of code and be like, whoever wrote this was an idiot. Now, when I look at a piece of badly written code, I'm like, I'm not saying what were they thinking in sort of an angry way. I'm actually saying, what were they thinking in sort of a more curiosity and maybe morbid fascination standpoint? But sometimes there's a good answer for that.
Yeah, what's interesting is this term of technical empathy is actually powerful and it's gaining some steam. So Cloud Foundry, one of the tests that we do to bring people into Cloud Foundry development, how do you get your committer status? You actually have to pass an empathy test, which is kind of unusual in sort of the historical domain of software engineering. But we've inherited that from Pivotal, right? So they do paired programming, extreme programming, and test-driven development. But one of the tests is can you manage to pair for a full day? Can you pair for a full week? Requires a lot of empathy. And then the net result is that you're also not going to say those people on that other team are idiots because they've been through the same process, right? So there's this sense of like, hey, we are actually trying to build build software a different way.
A friend of mine at IBM once said to me that the further you are away from the context that somebody else lives in, the more they look like an idiot.
That's very fair.
That's because, you
Yes.
know, most, I mean, there are some incompetent people, but most people are competent and they're proud of their work. And so if they're doing something that looks strange, it's because there's something in the context that they were working in that you don't see that led them to do that way.
Yeah, the perceived IQ is 1 over X, where X is the cognitive distance, right?
Cool. We have a couple of questions rolling in.
Microservices question?
Yes. So we have a question from Arvind. Does microservice architecture similar to what OSG architecture is?
Oh, good Lord!
Are there
I'm
any
under the table. No, it's not similar.
Martin, I'll let you answer this one.
Well, there are, you know, I think there's some similarities in motivation. I think the HTTP underpinnings is key. It's about how you decouple. It's very, you know, one of the things that we've learned over many languages and many environments over the years is it's very difficult to have a strong independent contract based on programming language constructs. So if you're running inside one language runtime and you're using typical sort of programming methods or interfaces, whatever your
What's wrong with Java RMI?
Extremely difficult to enforce a strong contract. So if you completely control both ends, you know, fine, do it within a language. If you're trying to deal with 2 pizza teams that work independently, deploy independently, I don't think that that's going to provide the kind of API that's going to allow you to succeed.
So this is interesting, actually. At the risk of taking too much time on this one, I've often compared microservices, at least in the initial intent, as I understood it by sort of reading Fowler, was that it was almost sort of an HTTP web service approach to the type of componentization you saw when you're using Spring Framework, at least from the scope of context, because everything in Spring is within your application context. And the same thing here. It wasn't initially when people were saying, hey, microservices are a cool thing, it wasn't, hey, microservices are a way that we do shared enterprise services in a more lightweight way. It was actually about saying, hey, I can scale my application and I can build my application faster if I treat it as a set of distinct components that still, for the most part, are built and managed by my pizza team or the pizza teams that I have a close affinity with, who I have a strong working relationship with. It wasn't sort of to go and say, microservices are the way that I deal with what Netflix calls the large set of unknown developers problem. Can you elaborate on the API proxy model? Does it mean API Gateway runs in a separate cloud from the PaaS platform? Would that lead to more network hops in case of microservices? So, good question. And I'm going to take a stab at answering this. The proxy model does not necessarily mean it's running in a separate cloud from the PaaS platform. It can. Obviously, you know, latency and network hops are going to be a factor. We can't get around speed of light, and so the distance between your proxy and the PaaS is something you're going to need to think about. It's not always an issue. This is one of these ones where anybody who starts talking about latency and is doing it in front of the whiteboard without actual sort of real hard data, I tend to lose a lot of respect for. Apologies to all the whiteboard architects out there. Because what I end up seeing is a lot of people, for example, doing a lot of worry about latency between 2 cloud services that are both hosted by Amazon in the same region, and the measurable latency is de minimis, but they still get all caught up on it. So measure it, see whether it affects your use cases. Obviously, it's more desirable to reduce that latency, and particularly in the case of microservices, minimize that. For a lot of ways of doing it. Apigee, for example, just released a micro gateway about 3 weeks back that's meant to actually be a embeddable gateway that you can use to eliminate the hops from proxy model, and there's other ways of getting around that. But yeah, something that
so I'm a big fan of having flexibility in that.
Yep.
You can deploy a proxy on the cloud, you can deploy a proxy close to your application, maybe even on the same machine or in the same container or in the same Kubernetes pod as your application, or even build your API management function into your application, as you know, open source projects like Volos allow you to do. But for me, the primary driver of that is not really latency, which in my experience is it's an issue you have to think about, but it's not a dominant issue. It's much more about units of packaging, units of deployment.
It's composability.
It's your DevOps. It's your DevOps.
Exactly.
Understanding that.
So one of the nice things about an API proxy is that rather than having your policy in all of the places, right, little bits of logic, right, stuffed into the apps, because that's what you could see is. You need to get to a point where the team with the same tools can say, well, we all have control over what the policies are, and we can adjust those and restabilize and alter them independent of the explicit lifecycle and update model for the apps themselves.
Absolutely. Yeah, and I think that's also, of course, that trade-off. But you do have these models where now, like with microgateways and so on, where you can have centralized policy management and decentralized policy enforcement.
Which is the ideal.
Exactly. Thank you all for watching. This webinar will be uploaded and viewable on the Apigee website, so check that out. And hopefully you'll all join us for our next webinar, and maybe given the interest level here, we'll do another one soon on this topic soon. Thank you.